Condenser fan motor. Question: when the condenser fan motor may need to pull air across the I'm not sure, I guess outside coils maybe, I'm not sure if that's the correct terminology, but they're like coils, so when the refrigerant comes through the compressor, it may be low pressure and then compressed into a high pressure vapor. Then it needs the cool air. Therefore, when one takes their hand and puts over the top in the summertime, one may feel the heat dissipating from the condenser as it pulls the air across it and then pulls the air in an upward direction. So now, sometimes it's easy to see something and a condenser fan is just connected. This one's rusted and it's got these little bolts, etc. But sometimes it's easy to overlook something simple. So now when observing a condenser fan and the blades, this is a 3-blade. I'm not sure, they may have 2, they may have 4, they may have 3. This particular one I think is a 1, 2, 3 blade. But as one observes this blade, one area is lower than the other area. Say for instance, if I put the piece of metal right here, and then I go down here, I'm not close because the right hand side of this particular blade is lower than the left hand side. So essentially the left hand side is higher, the right side is lower. So now the question is, what does airflow have to do with it? And this would be the reason we would have a condenser fan motor. It has a lot to do with it. Number one, it pulls the air across here, across these louvers, and then it dissipates the air so the refrigerant may be able to change state. So now getting to the point, which way does it turn? How do you know which way it turns? Well, if we look at this particular fan, the lower part of the blade is to the right. The higher part is to the left. Again, the lower part to the right, higher part to the left. So this would insinuate this would turn counterclockwise, I'm assuming. I may be wrong on this, but if I am, please do add this to the comments. So now, one way to think of this, or the way one school of thought, and this is just what I concocted in my brain, but it's not to say it's right, it's not to say it's wrong. But I go low. When the blade is low, the air is high. When the blade is high, the air is low. It according to which way it turns, according to which way. Some of these fans, this particular one is not the one. Some of these fans are reverse polarity, and they have a wire, like one can see the wires here, but some of them have another set of wires, and if you switch that wire, it'll change directions. But essentially, cutting to the chase here, if this fan spins counterclockwise, if this fan is lower on this side and this spins counterclockwise, the air would come up. It's grabbing the air and it's coming up. So if this fan now, hypothetically, if this fan turned in the other direction, the air would go down. Okay, this may be fine if it were a ceiling fan, but we need this air to come up, vertically up. So the way I look at it, and or my personal opinion is, let me rephrase that, my opinion is the air needs to come up. So in the summertime, if one comes out here and puts their hand a couple feet away from it and you feel hot air, this is dissipating the hot air. It's pulling the hot air in here, and it's coming up, it's coming upward in this direction. In order to do so, this fan blade is lower on this side, so it's cutting the air, so to speak, and the air is coming upwards. Okay, say hypothetically, if this fan reversed in the other order, what would happen if the high end started spinning first? If it went down, the air would go down. Well, if the air goes down, it may not pull the air across the condenser, so therefore it may not work properly. Now, if it were a ceiling fan and you wanted the air to go down, if you look at your ceiling fan, normally, maybe perhaps in that scenario, you would want the high end spinning first. So it would spin. If it spun this way and the high end was up, it may push the air down. But if you had a reverse ceiling fan, you could do it. But when you're talking about a condenser fan motor, you need this condenser fan motor, you need the air to be coming up, say up towards the clouds or the sky or whatever, whatever mnemonics you can use in order to do this. So in order to get the air up, the lower end needs to be spinning in that order. So in this particular case, on this particular unit here, it is fairly rusty, as one can see, but notwithstanding. But if one can see here, this blade here may turn counterclockwise according to the blade. So the lower end would do this, and then the air would come up, and when the air comes up, it has kind of like maybe, and it'll pull the air across these louvers, across these coils, and then the air should help cool the coil. I'm not sure if the coil, it's not an A coil, it's a condenser. Yeah, I call it a condenser coil, but if there's a better name, please add that to the comments. But notwithstanding, you're pulling the air off of here, dissipating the heat so that the refrigerant can change from vapor back to liquid, and then it goes through a 360-degree cycle. So to rehash, lower blade, they go in inverse order. So the lower the blade, the higher the air. So if the blade's low and it turns in that direction, the air comes high. If the blade is high, the air goes low. So just think in opposite directions. So if the fan blade is low, like turning on the low side, as one can see here, this side's the lower, so it would turn this way. So if it's low, then the air comes high. If this is the high side of the blade, if it were to rotate this way, then the high side would blow the air down. So it would, in my opinion, and if there's something that needs to be added, feel free to add it. But once it blows the air down, then so the high side down, low side up. Just think in reverse, in inverse, not reverse, inverse order. So low, high, high, low. Condenser fan motor, the way it spins, and to help condense the HVAC or air conditioning refrigerant. Thank you for watching. Have a great day.